The Sun, the star at the center of our solar system. Its surface rages with violent eruptions, magnetic tornadoes, and mysterious dark spots.
The sun is essentially a big, giant ball of plasma, and it's just pouring out energy.
Where does the sun's vast power come from? How was our star born? And could its immense energy one day consume our planet?
The sun is both the bringer of life and the ultimate destroyer.
To find out, we will strip the sun, peeling open its searing layers, diving deep into its core, revealing the secrets that lie at the heart of our closest star. "90 million miles from planet Earth, a cosmic powerhouse shapes our world. The Sun, a giant nuclear reactor 1 million times bigger than Earth. Its influence extends to the furthest regions of the solar system. It supports all life and protects us from a harsh galaxy."
The basic building block of the universe is a star, and the sun is a star. The more we know about the sun, the more we could learn about the universe itself.
All of the energy in my body that I'm using to speak and to move originally comes from the sun.
The sun giveth and the sun taketh away. So the sun gives us life, it sustains us, it protects us, but it can also wipe us out in an instant.
The sun is more than a ball of gas. It's a complex engine. The outside is an ocean of roiling plasma. Below that is a bright layer dotted with dark and violent sunspots. 120,000 miles deeper, plasma swirls in giant vortices, pushing the sun's heat to the surface. Down in the core, a nuclear furnace produces the energy of 100 billion tons of dynamite every second. All these layers work together to make a colossal cosmic engine that powers life on Earth. But there's a dark side to all this energy. These real-time satellite images show lethal solar storms raging on the surface of the sun. At its most active, it can spew out 20 of them every day. These energy surges blasting our planet can damage power grids and cause citywide blackouts.
These aren't made-up science fiction movies coming out of Hollywood. We get solar storms all the time, but a really big one could actually bring our civilization to its knees.
The U.S. Air Force is right in the firing line of the sun. Solar storms can fry communication satellites, endangering the life of anyone on board an aircraft. That's why the Air Force has eyes on the sun day and night. The men and women of the 2nd Weather Squadron scrutinize the sun's activity 24/7. The man with his finger on the solar pulse is Staff Sergeant Aaron O'Connell.
So my job, in a simple way to phrase it, is watch the sun and report any activity that might occur on it.
The sun can brew up a storm without any warning. The surface of the sun is a highly volatile layer of plasma, 1,500 miles deep. Violent magnetic fields force their way up through this roiling mass. The fields rip off loops of solar matter thousands of miles high. Some of them collapse into solar flares, releasing bursts of radiation. Others erupt as huge firestorms, ejecting billions of tons of superheated plasma at millions of miles an hour. These sunstorms take just a few days to reach the Earth. But the radiation from a flare can hit us within minutes, creating a deadly threat to airborne flights. So Sergeant O'Connell's telescope constantly monitors the sun's surface for solar flares.
We do have a region that looks like it's getting bright enough to possibly produce a flare. Right now, it is bright enough for a flare, but it's not quite big enough. So we can go ahead and continue to watch it, monitor it.
The Air Force isn't the only organization watching the action unfold. Millions of miles from Earth, a fleet of NASA satellites zooms in on the bright region. This volatile area could erupt at any time, shooting deadly radiation towards aircraft on Earth.
It's wildly caught up. If I hear that 3-alarm burst, then I'm very worried.
The alarm tells Sergeant O'Connell that the flare has begun to erupt on the surface of the sun.
So that's the start of our flare.
The cause of this brewing flare lies buried deep within the sun. Magnetism. The sun's magnetic field originates 120,000 miles below the surface. Here, one layer moves faster than the layer below it, shearing the highly charged plasma in between. This generates massive magnetic fields throughout the sun. These powerful fields pierce the outer layers, pushing up towering loops of plasma that can erupt without warning. It's a tense time for the Air Force's 2nd Weather Squadron. For now, they can only watch and wait for the sun's next move.
That's our end flare alarm. This region's no longer flare bright, and that's the end of our flare.
This time, we're lucky. The flare died down before it could escape the sun and hit the Earth. Our sun demands constant vigilance, but other stars have an even more violent temper. The cosmos seethes with magnetic ferocity.
When we consider the danger that the sun poses, one of the big dangers has to do with its magnetic fields. It has strong fields, and the size and strength of the field is related to a star's rotation rate. So when stars are young, they rotate much more quickly, and they have much more powerful magnetic fields, which means more powerful explosions on their surface.
One of the most explosive young stars lies 16 light-years away, E.V. Lacerti. It's 3 times smaller than our sun and 100 times less bright. But this tiny stellar infant packs a punch. Spinning 6 times faster than our sun, its magnetic field is 100 times stronger. In 2008, E.V. Lacerti produced the largest starstorm ever recorded. Thousands of times more powerful than any storm from our sun. Thankfully, our planet was too far away to be hit. The sun is not nearly as violent, but much closer to Earth. The next big solar storm could arrive at any time. A direct hit could wipe out power across an entire continent. So how can we survive the next big strike? violent and volatile, our 5-billion-year-old sun becomes more dangerous as it ages. The sun's chaotic behavior threatens technology across the planet.
Weather forecasting, communication, banking, the internet, all of that would be damaged, if not destroyed, by a big solar storm. The warning system that we have in place now is better than nothing, certainly. Is it enough? I would say no.
But the sun offers clues that can help us predict its behavior. Pulling away the loose gases of the sun's atmosphere reveals black disks the size of a planet that drift on a layer of boiling plasma. Sunspots. Slicing through them reveals they are more than skin deep. Areas of darkened plasma extend far below, stretching thousands of miles into the sun's interior.
Whenever you see these spots, you know that the magnetic field is very intense and very violent in those areas. So when you see lots of sunspots, you will also see flares and prominences and things being thrown off the sun.
But by the time we see sunspots from Earth, we can already be under attack. How these dark patches form could be the missing link in predicting solar storms. At the University of Birmingham, Bill Chaplin is on a mission to increase solar warning times from minutes to days. Bill thinks the key is not just watching the sun, but also listening to it.
And just below the visible surface of the sun, then the gas is very turbulent, so there are lots of very rapid changes in pressure. The gas is whizzing everywhere. And what that does is it makes sound. And what we're doing is we're actually measuring the effects of these sound waves inside the sun.
Bill's network of 6 observatories around the world detects the sun's surface moving back and forth and records the sound this motion creates. These real-time sounds reveal what's happening below the surface. If he can identify what causes the sound waves, Bill can predict when the sunspots will occur. Bill believes the source of these sounds lies deep inside the sun, where sunspots are born. 40,000 miles down, huge convection currents swirl the plasma in endless circles. When magnetic disturbances touch the currents, the plasma cools and darkens before rising at 1,300 miles per hour, creating turbulent sound waves. 2 days later, it emerges as a sunspot, a warning that a deadly eruption could be just days away. For Bill, recording the sounds of the sun is the easy part. Working out what they mean is the real challenge.
So the sun is playing these notes all the time, but if the notes get a little bit higher or lower, it's telling us about ways in which the conditions in the sun are changing. So if the sun were to get a bit more active, then the sound of the note might get a little bit higher. And then as the sun goes into a less active phase, when it's much quieter, the sound will be lower.
The goal now is to predict the sun's behavior several days in advance.
In terms of being able to predict what's happening in the future, we're working on that. The more we carry on listening to the sun, the more we will understand about it.
Sunspots do more than unlock the mysteries of our own star. They also highlight just how odd our solar system is, compared to the rest of the cosmos.
Evolving here on the Earth, we've developed this wonderful blind spot. We sort of look at the conditions around us and we say, hey, those must be the normal conditions for the rest of the universe. But in fact, there are some ways that we are substantially different from the norm. And one is that we only have one star in our solar system. Most stars in the sky live in binary star systems, where there would be two stars. When you have two stars living together, evolving together, there's no reason the relationship has to be equal.
There's a seriously dysfunctional relationship playing out only 90 light years from Earth. VW Cephei. It's not just one star, but two, joined together. The smaller parasitic twin slowly feeds off the bigger one, which drives the star's magnetic fields crazy. This creates so many star spots that more than half of VW Cephei's surface is cloaked in darkness. Our lone star system is a haven in a violent cosmos.
The further you go from home, the scarier it can get, and it seems kind of tranquil. But the reality of it really isn't that at all. It's really chaotic.
The source of our own star's chaotic behavior comes from the most extreme place in the solar system. A giant nuclear reactor 10,000 times the size of Earth. The core. Could we one day harness its immense power? The sun contains over 99% of all the mass in the solar system. It produces 9 million times the United States' annual energy consumption every second. The source of this enormous power lies deep inside the sun. The core. 10 times denser than lead, it burns at 27 million degrees and behaves like a gas. Extreme pressure fuses hydrogen atoms into helium, spitting out the energy of 100 billion tons of dynamite every second. This gigantic thermonuclear warhead powers all life on our planet.
When you get up in the morning and flip on a light switch, turn on your computer, get in your car and turn it on, you're using energy that was generated by the sun and has been stored here on Earth for tens or even hundreds of millions of years.
Sunrise in the Mojave Desert. A team of engineers prepares to harvest the sun's energy with a radically new type of power plant.
It's a solar plant, but it's not a solar plant you're normally used to. It's not the panels you see on people's houses. It's different than most anything you've ever seen.
For solar engineer Stacy Browning, the sun is her most important resource. To harness the sun's rays, Stacy's team uses 340,000 garage door-sized mirrors, spread over an area 4 times bigger than Central Park. They're called the solar field.
These don't absorb the heat and the energy from the sun. These are mirrors. They truly reflect the sun's rays up onto this boiler, and we boil water, we make steam, and we make electricity.
The mirrors funnel the sun's energy particles to a single point. 4 stories high, it's called a power tower. It turns water into steam at 1,000 degrees, driving 3 turbines to produce electricity. Harnessing sunlight this way requires ultimate accuracy. If the mirrors miss their target, the turbines will grind to a halt.
So the accuracy of the mirrors out here in the field is one of the most important things. When all of these were put in, they were geolocated and had to be within half an inch of the planned location.
The light hitting the tower left the sun only 8 minutes earlier. But this was just the final stage of an epic journey that began millennia ago. Before light can emerge from the surface of the sun, it must undergo an incredible transformation. It all starts deep in the heart of our star. The nuclear furnace in the core spits out energy as lethal gamma radiation. Unfiltered, straight from the core, these rays would destroy life on Earth. But there's more to the sun than just the core. A layer of plasma 10 times denser than rock wraps around the core. As radiation squeezes through the dense body of the sun, it becomes less and less aggressive. And after 170,000 years, it finally reaches the surface, transformed into the sunlight we see. Capturing this sunlight at the solar field isn't easy. With the plant at maximum capacity, Stacy discovers a problem. One of the mirrors has stopped pointing at the power tower. She heads to the solar field to track down the rogue reflector.
ID number is Hotel Echo Charlie. I will put it back in its original state. Thank you.
140,000 homes rely on the power the field generates.
All better.
An average of 340 days of sunshine a year makes Stacy's plant the perfect way to harness the sun's energy. Our sun is not the only star in the cosmos with such a huge energy output.
The sun is really close, and so therefore it has a huge consequence for life here on Earth. It looks big compared to the other stars, but actually, the sun is a really small star. There are some absolute monsters out there.
One of the most extreme monsters in the galaxy lurks 250 light years away from Earth. The giant star Bellatrix. 6 times bigger than our sun, it shines 4,000 times brighter with blue fire. Inside, the core is in nuclear overdrive. Bellatrix burns its fuel so fiercely, it will live fast and die young. If the lifetime of our sun were a single day, Bellatrix would only live for a few minutes. Our star may be small, but its stable core means it will continue burning steadily for 5 billion more years. But that doesn't mean it'll always be a good neighbor. The sun is hiding a killer menace that stretches throughout the entire solar system and threatens anyone in its path. Earth lives in constant danger from solar storms. But our sun has another silent threat. It reaches across the entire solar system and even jeopardizes human space travel. Its source lies at the very heart of our star. The hottest place in the solar system rages 400,000 miles beneath the sun's outer layer. The sun's core. It pushes energy up to the surface, but it doesn't stop there. The force of this flow also ejects 4 million tons of solar plasma into space every second. This creates a gigantic streaming cloud of corrosive exhaust gas. It burns at 1,000,000 degrees, 200 times hotter than the sun's surface. This is the solar wind. Our planet's magnetic field forms a natural shield. It deflects the solar wind and creates the light shows we call aurorae. We're safe on Earth, but as soon as we move away, we're totally exposed.
I think it's actually the biggest obstacle we have for exploring our universe. It's like being in a nuclear reactor. So we need to protect people when they go out into deep space where they can get radiated.
NASA Langley. A team of scientists race to launch a new generation of American astronauts into deep space. Engineer Jeff Serro investigates how to protect them from the sun's radiation.
The dark side of the sun, from the sense of living in it as an astronaut, is the fact that it throws off these solar particles that actually come through space station walls and pass through astronauts and cause long-term bodily damage. So the work that we're trying to do here is to shield the astronauts from radiation. It's like wearing a coat against the bad weather.
But the solar wind is nothing like the Earth's weather. Highly charged particles hurtle through space at 1,000,000 miles an hour. Since the sun first ignited, the solar wind has shaped the solar system. This is Mars, 4 billion years ago. Water covers its surface until the solar wind rips off the atmosphere and bakes the planet. Whenever humans venture into space, we cannot escape the fallout from our star. Jeff and his team must find ways to shelter astronauts from this solar onslaught. They're testing a radically new idea.
You've just received notice that a solar particle event is likely to occur in 20 minutes. Please complete the shelter as quickly and as completely as you can.
A temporary panic room where astronauts can shelter from deadly spikes in solar radiation.
Okay, go.
You can't build a big shelter, a big heavy shelter, because it's very expensive to launch things into space, $8,000, $10,000 a pound. So you're trying to build a shelter out of items that you already have.
Jeff can't build a bigger spacecraft.
You want air?
Instead, his team tests if astronauts can build a shelter from materials already on board. Anything that contains hydrogen, like waste, food, or water, is a perfect ingredient. Weight for weight, water is a better radiation shield than steel.
Water is something that we need to live on anyways, so we like to use hydrogen and water.
To survive a solar storm, the astronauts must be quick. If they can't build a shelter in 20 minutes, their bodies will be bombarded with deadly radiation.
So they completed in 16 minutes and 41 seconds, which is well within the warning period for the solar particle event.
Scientists like Jeff want to protect astronauts from dangers originating within our solar system. But our galactic neighbors send something even more deadly our way: galactic cosmic rays.
When a star explodes hundreds of light years away from us, it actually produces incredibly energetic particles that we call cosmic rays. By the time they get to Earth, a single proton, a tiny little particle, can have as much energy as a 100-mile-an-hour fastball.
If the cosmic particles were to reach us unfiltered, their speed and energy could slice human DNA in half. But protection comes from an unlikely source.
You might think of the sun as the bad guy because it has these magnetic fields that rearrange themselves and cause these explosions, which cause solar storms here on Earth that can affect us negatively. But it's that very same magnetic field that protects us from very dangerous cosmic rays.
The solar wind radiates throughout the entire solar system, dragging the sun's magnetic field along. It balloons out to form the heliosphere, a gigantic bubble of highly corrosive particles that can also deflect radiation. This solar force field shields us from lethal galactic rays pouring in from the cosmos. Without it, life on Earth would be impossible. The sun is just one of billions of cosmic engines that light up our galaxy. Could the discovery of how these stars form reveal the origins of the solar system and the explosive fate that awaits us all? The sun created all the planets in the solar system. Its power nurtures the only known life in the universe. Now, scientists around the world want to solve the mystery of where our precious star came from.
The more we know about the sun, the more we could learn about the universe itself. Where did the sun come from? What's it going to do in billions of years? The only way we can find out is by looking at nearby stars and seeing how they're different from the sun, how they're similar. Studying those will tell us about our past and where hopefully we'll be heading in the future.
Scientists believe the sun's origin stretches back almost 5 billion years, when our solar system was a swirling mess of dust and gas. Stripping open this dense cloud reveals an embryonic star forming from the rubble. Over time, the pressure in the cloud's center cranks the heat up to over 18 million degrees. Now, it just needs a spark to ignite. For astronomers like Chat Hull, witnessing that moment of star ignition is the holy grail.
Well, the hardest part about getting images of stars that are very, very, very young is the fact that they're behind dense clouds of dust and gas that keep telescopes like Hubble from actually being able to see all the way in. So you have to use different kinds of telescopes to zoom in all the way through that dust and gas to see what's going on in the very center.
Chat's team uses KARMA, an array of 23 giant antenna dishes, to scan galaxies for infant stars. Chat must clean the supercooled instruments at the heart of these dishes that let him glimpse stars forming light years away.
So stars don't just appear. They appear eventually, but what they do is they form out of these clouds that are, in a sense, stellar nurseries. Many, many stars are being born in the clouds that we look at with telescopes like KARMA.
Nobody has ever observed the exact point when a star is born. A birth can take thousands of years. But Chat thinks his antennas have found something. 500 light years away, hidden deep within a cloud.
Yeah, that's incredible.
It's called a protostar. This infant sun-like star is close to formation.
So what I'm looking at is what is deep within the cloud. That's the real deal. Yeah. This is what will eventually turn into something like our sun. Now, right now, this thing is completely obscured by dust on every scale, not just on this very small scale, but on much larger scales too. And so we are using KARMA to cut all the way through all those outer layers of dust.
But this young protostar lacks one vital ingredient.
There isn't nuclear fusion in this yet. So the definition of a protostar, technically, is a star that's still in the process of forming but has not yet ignited nuclear fusion in its core.
Ignition is the final stage in a star's birth. The pressure on the protostar at the center of the cloud becomes unsustainable. It's like Mount Everest squashing down on a car. At 25 million degrees, nuclear fusion kicks in, and the core ignites. The explosion blows away the cloud of dust and rock and leaves behind a naked, newborn star.
A star like this that's about 100,000 years old, if you take that as a percentage of its, say, 10 billion year lifetime, that's the equivalent of having a baby who's about 9 hours old if he or she is going to live to be 100 years old. So the very, 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 very beginning of the life cycle.
The stellar nursery our sun came from is a mystery for astronomers.
We know that stars are born in giant clouds of gas. Sometimes they're huge, vast, sprawling complexes that build thousands of stars all at the same time. Sometimes they're little, and they form 1 or 2 stars, just sort of solitary and isolated. We don't know if the sun formed by itself or in one of these mega stellar nurseries. The only way we can know is by studying the sun, studying the other stars around it, finding other stars that are like the sun.
The most famous star nursery in the cosmos is 7,000 light years from Earth. The pillars of creation. Stripping away their impenetrable clouds of gas reveals thousands of stars and clouds of extremely dark dust. Deep inside them, new stars are forming, surrounded by dust clouds that turn for millions of years. Most stars born in these stellar nurseries will live for billions of years. But like our sun, they'll eventually run out of energy and die. When that day comes, they won't go quietly. The sun anchors our solar system. Its raging nuclear fire and brilliant light provides all the energy for life on Earth. But the sun won't live forever.
The thing about stars, like the sun and all other stars, is that they're kind of like people. They're born, they evolve, and they die. And there's a real irony to living around a star like the sun, because it gives you the life-sustaining energy that we need that powers all life on Earth. But eventually, that same sun is going to take out the Earth, and all life on Earth will cease to exist.
In California, Chat Hull and a team of astronomers search the universe for dying stars and clues about our sun's fate.
It is essentially a cosmic circle of life. Yeah, you have dusty star-forming regions where stars are born, but a few are more massive than our sun, and in some cases they explode into violent end-of-life events called supernovae.
Supernovae are the final moments of dying stars. When a massive star has used up all its fuel, it changes dramatically. Instead of hydrogen, its inner layers are brimming with heavy elements: carbon, neon, oxygen, silicone, and iron in the core. The star becomes so dense, it can no longer sustain its weight. It collapses and explodes, spreading fragments of its corpse all over the galaxy. The death of a star is more than just destruction. It's all part of the cosmic cycle of life.
Oh yeah, these things are massive. We have a couple of examples here. So when these supernovae go off, they create a massive shockwave. The shockwave can slam through clouds of dust and gas nearby to where the star exploded. And when it plows through this cloud and is able to start forming stars in the clumps that have been created by the shockwave. Supernovae are really kind of the end, or the beginning, depending on how you look at it, of the cycle of birth and death.
A supernova may have ignited our young sun, but scientists believe a different death awaits our star. Once all the hydrogen in its core is spent, our sun will switch on its afterburner. The core will collapse and heat up, igniting fusion in the outer layers. As these layers start to burn, the sun will begin to die a slow death. It will inflate and become a red giant. The sun will consume the Earth, and finally, the sun's outer layers will burn off. All that's left of our star will be a glowing carbon ember that will eventually fade into darkness.
It's the story of all of us, I suppose. The stars eventually will go out. There are more being made all the time right now, but eventually they will stop being made. There will be no more gas in the universe to create stars. And someday there will be a last star, a couple of trillion years from now, some tiny red dwarf, faint, cool, and it will fade away with time, and the universe will be dark.
But our middle-aged star will live for a long time.
The sun is a few billion years old right now, and it's going to live to be maybe about 10 billion years old. So we have another 5 billion years or so before this happens. So we're safe with our normal sun for now. I think it'll have lived a good life.
For now, we live side by side with the sun and bask in its light.
As the sun goes through its life cycle, the planet Earth is going to go through a life cycle right along with it. And us passengers on Earth, we're going to be a part of that life cycle.
We may never fully understand it, but using the knowledge we have about physics and math, science and astronomy, we're learning more about it every day, and I think that's critical to our own future.
Our sun is a perfectly tuned cosmic engine. A nuclear core that produces vast amounts of energy. A dense, bubbling body that tempers the radiation. And an atmosphere that creates a protective bubble around the entire solar system. Our star will support life on Earth for millennia to come, as long as we learn to live with its dark side.